All right. Hello, everyone. Thanks for coming. I know it's the end of the day, and you're probably dragging as much as I am. Before I start, I want to get a quick show of hands. Who in here has actually written a project with TypeScript? A lot. Okay. What about TypeScript plus GraphQL? All right. Not quite as many. Awesome. Okay. So let's talk a little bit about GraphQL. NPM recently did a survey, and they found that 23% of all developers are using GraphQL in projects today. That's a huge number for a tech that was really only released 4 years ago. Even more impressive, nearly half of developers are considering using it this year. This is explosive growth. The most recent State of JavaScript survey showed us this change in GraphQL popularity over time. You can see that awareness increased significantly. Developers interested in learning it grew by more than 40%. And developers that have used it and love it have quadrupled. And that's probably not a surprise because we're at a GraphQL conference here. So let's talk about TypeScript. That same NPM survey found that a third of users in the JavaScript community are writing TypeScript some or part of the time. That's a third of users writing a totally new flavor of JavaScript. That's, to me, very remarkable, and it should make us sit up and take notice. So what is TypeScript? It's essentially a statically typed programming language that compiles down to JavaScript. TypeScript is what you write in this top example, and it outputs the JavaScript that you see in the bottom example, and that's what actually runs. It's an open source project backed by Microsoft. So what do we mean by statically typed? Statically typed is just when a language determines the type information. These are a few examples of languages that are in each paradigm. Which one is better is sort of a hot topic. They both have advantages and disadvantages. I wouldn't say one is better than the other. But one implication of this is when errors are discovered. Is it at runtime or is it at compile time? Compile time errors are much better for users. So error handling is better in statically typed languages, but what else? I can say after using both languages for a while in large projects, I can't imagine writing a large project in JavaScript. I would go for TypeScript 100% of the time. Static type languages have the proven ability to enhance code quality. Large teams at companies like Google, Microsoft, Facebook have come to this conclusion over time. Static typing eases refactoring. They increase your agility when you're doing renames, refactoring. You saw before the compiler catches errors as you type instead of having things fail at runtime. They're also one of the best forms of documentation you can have. It forces you to think about the shape of your data up front and document how it works. The function signature is like a theorem, and the body is the proof. Here's a simple React component. Any consumers of this component can see what props it accepts, and it's enforced by the compiler. Finally, static type languages enable IDEs to provide a rich environment for spotting common errors as you type. Here's an example showing autocomplete as well as renaming. It's also important to note that this works across files in your project. And here you'll see I'll rename the MSRP field, and at the same time it will update the interface for product. So going back to the State of JavaScript survey, you can see TypeScript's popularity over time. Developers who have used it and love it has more than doubled. And the number of devs that are not interested at all has been cut in more than half. Among developers who like to use both, these are the most liked aspects of the languages. And you can see that those users like them because they unlock the ability for us to create powerful developer tooling and strongly typed, less error-prone code. In today's talk, we're going to focus on developer tooling that works at the intersection between GraphQL and TypeScript. Before we go on, just a little about me. I've been a professional developer for over 20 years. I work remotely from Lafayette, Louisiana. I started primarily as a PHP developer, eventually moving to the full-stack JavaScript ecosystem, and I now focus on that at Formidable Labs. Formidable is a software consultancy that focuses on that same ecosystem. We work with companies of all sizes, from startups to Fortune 100s. We have many popular open source libraries. If you see anything here that you like, that you think we could help your company with, please come talk to me. And also, we're hiring. We're almost always hiring. So when I was kind of come up with the idea for this presentation, I wanted to come up with like an example application I could use to demonstrate the sort of the philosophy, the technique here. First thing I thought of was like a to-do app, but that's really boring. At the time I was working on this, Game of Thrones was like in its final season, and I really loved that show. So I said, okay, let's do something with that. Let's build a character explorer using TypeScript and GraphQL. I'm not going to show all of the code for the app, just the important pieces. And we'll take two passes at it. First, we'll kind of write a naive implementation, and then we'll come back and try to make it better. So before we go on, who else watched Game of Thrones? What did you think of the ending? I don't know. All right, so let's go to the server. Before we get to the TypeScript specific stuff, I want to give a high-level overview of how a GraphQL server works for those that haven't done that before. I find that a lot of times people only work on the client side of things. So if you already know the server-side stuff, this will be a refresher for you. You essentially need to provide a GraphQL server with three things: a schema, resolvers, and context. These are the three main building blocks of every GraphQL server. And we'll look at each of these in a little more detail. So the schema is the core of everything. This is where you define the operations that your application supports. Here's the schema we're going to work with for the rest of this talk. I'll pause for a minute so you can read it. So let me highlight a few things here. So our main entity is a character, and we have these two queries that return a list of characters or a single character. Each character can have appeared in many of these TV season entities. And a character can also have allegiances to many of these house entities. And finally, another query that returns a list of houses. So let's move on to the resolvers. A GraphQL resolver is just a function that returns something. They're written for all of your queries, mutations. You can write them for fields and more. Here's how a resolver is structured. You essentially provide an object with a key for each type in your schema. Inside of that keyed object is a resolver map. So this is an example of a resolver map for the query key. Notice that there's an entry for each query in the schema. And each one of those entries is a resolver function. This is the shape for all resolver functions. You might not use all 4 parameters every time, but they're available if you need them. The parent contains the root element or the parent element, depending on where you are in the schema. In this case, it's the root because this is at the query level. But if you were writing a resolver for a field under the character, for example, then the parent would represent the character entity. This is the arguments for the query or mutation, if they exist. Context is an object shared among all resolvers of a specific execution, and we'll discuss that in a minute. Info is only used in advanced cases, and then we have a return type. And here is how that all lines up with our schema. So context is the third major building block. Like I mentioned, it's an object shared by all the resolvers. It can be anything you want, and it's newly created on each call. It's useful for keeping data like you see here, authentication information, the current user, a database connection, and it's specific to your application. So whatever you need it to be is what it is. So just to recap, these are the three fundamental pieces of a GraphQL server. So let's look at some resolver code. This is just a subset. I removed a lot of it. But let's see how we can define types for it. First, we have our top-level resolver object that has an entry for each of our entities, which you can see underlined in green. Each one of those is a resolver map, also underlined in green. We're using an index signature here because our resolver maps can have many fields. Those fields contain resolver functions, and they just need to match this function signature. Notice how the parent or the root element there is any. In some cases, we want that first argument of our resolver function to be more specific than that. In this example, we know that the parent of the appeared in field is a character, so we can add a manual type definition there to improve safety. So this is pretty cool. We have mostly type-safe resolvers. Now let's make a web app to consume our new GraphQL API. I used Create React App to bootstrap the front end, but I'm not going to go into details or show that. A GraphQL client library like Apollo is not necessary, but it helps, especially with caching and batching and things like that. In our examples, I'm going to use a library from Formidable called Urkel. Urkel is a lightweight, powerful, and easy-to-use alternative to other GraphQL clients. It's small, which really helps with performance. There's no complex configuration or large API overhead. It's built around the concept of exchanges, which is similar to like middleware in Redux. It allows you to customize your data layer to suit your needs. For example, different caching strategies, custom developer tools, etc. It works very similarly to other libraries like Apollo. You wrap your app with Urkel's provider component. This provider holds the client that is used to manage data, requests, the cache, and everything else. It's the heart of Urkel. It holds all of the core logic. Every component underneath the provider now has access to the client and will use it when it needs to make GraphQL requests. Urkel comes with hooks that can be used to declaratively fetch data from your GraphQL server. Here's an example component that uses the useQuery hook. When this component is mounted, it will send the query and variables to your GraphQL API. We then get a few variables to tell us about the state of that request, like fetching, error, and data. That should be enough about Urkel to get us started, so we can now write a React component that renders a list of characters. When I'm working on a component, the workflow I like to use is to start with the query, so I know exactly what data my component needs before I write any code. Sorry. This is the query we're going to use in our component, and it should give us all the data that we need. So now let's use that query in our component. React hooks are great. So let's use the useQuery hook that we just learned about. You can see how simple and declarative it is. First, we display a loading state, and then standard React syntax to loop over the data and render. Now let's check out the type definitions. Fetching is already typed by Urkel as a Boolean. However, data is not. We need to define a TypeScript interface which matches the query that we wrote in the previous slide, and then pass it as a generic to the useQuery hook. And the query variables, unfortunately, there's not much type safety here. But we have a mostly type-safe component, which is pretty great. This was our first attempt, and I think it's pretty great. We have a type-safe server and client application, but there are a few problems with this approach. It was really tedious to manually type the resolvers, and there was a lot of duplication. So let's go back to the server resolver type again and compare it with the schema. And look at all the manual duplication we have here. The entities are duplicated, the resolver object is duplicated, and our resolver map and resolver function arguments are typed with any. It doesn't give us much confidence. Let's go back to our front-end types again and compare that with the schema. We see more of the same here. The query name and return type are duplicated. The character entity is duplicated. Parts of the TV season are duplicated, and same with the allegiance entity. And here's another problem. What happens if we make a change to the GraphQL schema? Let's change the name field here on the character entity to be optional. Those types that we wrote in our resolver and in our queries are now wrong. But TypeScript won't throw an error because it doesn't even know about them. The user gets a runtime error, which is bad. So type-safe code isn't enough. What we really need is type-safe code based on a single source of truth. We need one place to define our types that works across our stack. And I contend that the GraphQL schema should be that single source of truth. That's all well and good, but how can we actually accomplish that in an automated way? GraphQL Code Generator is an amazing CLI tool that understands your schema and can generate types and code for you. It's really great. You've probably heard it mentioned at previous talks today, and lots of people are taking notice. So let's start by going back to our resolver and changing it to use the generated types. Here's an example configuration for the tool. Don't worry about all the options. I'm just going to point out a couple of things. This field tells the tool where to find your GraphQL schema. And this field will tell the tool where to actually output the generated code. Here's an example of some output that you'll get. It's not important to understand all of this stuff, but I wanted to show you what it generates to prove that it's not magic. Here are our entities, resolvers, details about the query resolvers, and then details about the get characters query, the parameters, and the return type. So let's update our resolvers to use the generated types now. So you remember this? Not great. I love her. So we can remove all of the manual duplicated types. The only thing we're using is this one imported interface from the generated code, but everything is still fully typed. Context, arguments, and return value. Now let's make a change to the schema by removing the sort direction parameter here. To me, this is the coolest part. We immediately get a helpful TypeScript error showing us the places in our code that need to be updated for that schema change. The user won't ever see this error because we fixed it at compile time. And as I mentioned before, compiler errors are better than runtime errors. Littlefinger agrees. So let's go back to the front-end app now. So we're going to look at config again. You don't need to understand all the pieces of it. I just want to point out a few things. So this documents field is where you tell the tool where to find all of your queries and mutations. This is the file that it's going to generate. And then finally, it has a plugin system that supports many popular clients, including Urkel, Apollo. What this plugin does is it not only generates types that work in Urkel, it actually generates components and hooks, like fully functional React components. So here's a snippet of the output. Again, it's not important to understand all of this stuff. I just wanted to show you what it generates. But the most important part is this React hook that it generated, used character list query. So let's update our component. So this is what we had before, and this is what we have now. We are only using that single generated hook, but everything is still fully typed. Check out all of the IntelliSense we get from this single import. Let's make that same schema change again and see how it affects the client. We see again, we immediately get a helpful TypeScript error showing us the places in our code that need to be updated. And again, the user won't ever see this error because we fixed it at compile time. So what have we accomplished? We now have a fully type-safe client and server, but most importantly, it will stay in sync as we update our schema, queries, and mutations. In our first attempt, we did pretty well, but there were some problems. But our final approach solved nearly all of these problems. Before I finish, I wanted to say a moment about this project. Open source powers so much of the world today, and maintainers often end up burnt out and unappreciated. So I wanted to give a public shout out to Dotan for all the work he does on this tool. Thanks for coming. If you'd like to chat about anything, please introduce yourself.